I'm Anil Kumar. Welcome to my series on calculus. We're discussing some very important applications of derivatives. The question here is find approximate value of square root of 65 by using tangent approximation to f of x equals to square root of x. You can always pause the video, answer the question, and then look into my suggestions. Now let's try to understand the situation here. Now this is a very important question, and we do these approximations to find answers without calculator also. So let me show you what we're trying to do here. The square root of x function will look something like this, right? So that is square root of x. Let me write down here square root of x. Now, we know that square root of 64 is equal to 8. That is the exact value which is known to us, right? However, what is square root of 65? That we don't know, right? We need to figure this out. But we know that 65 can be written as 64 plus 1. Right. So we can kind of approximate since it is very close to 65. That's the whole idea, right? So it can be approximated by finding the value at 64 and then approximating. So the approximation by tangents is something like this. If I draw a tangent line at x equals to 64, the tangent line could be kind of like this. Correct? Let us say this is our tangent line, and the point of interest is this particular point where for 64 x value, we have a y value of 8. Is that clear to you? So let's break this a bit. I want to kind of give you a wider view so that you can appreciate what we are trying to do here. So what we will do is we'll figure out a point. Let us say that 65 is somewhere here. Let us say this is 65. Now, actual value of square root of 65 is that. That is the correct answer. But what we are going to do is find this answer, which is approximate. Do you get the idea? The point on the line which is tangent at 64, and then substituting 65, we get our value. Do you get the idea, right? So that is the whole thing. Now, let me give you one more concept as we move forward. We know slope is equals to rise over run. Correct? You can say tangent of theta, rise over run. So at this stage, if I construct a triangle, let us say like this, right? So this becomes a triangle for me, correct? Now in this particular triangle, we know that the run from 64 to 65 is 1 unit, right? So in this case, we know that the run is 65 minus 64, which is 1 unit. Is that clear to you? And what we really want to find is the rise. What we want to find is the rise, correct? So let's say the rise is h. In that case, let's say rise is h. In that case, slope at this point, right, is equal to h over 1. Do you get the idea? So in our case, the slope is basically indicative of the, we could add this value h to the original value 8, right? So once we add this value h, we get 8 plus h as our answer. Do you see that? So this is actually square root of 65, approximately. Does make sense to you? So this is the concept which we are trying to use. So in this, since the difference is only 1, it is directly equal. That is what it is. Perfect. So you got the base. This is just an idea which helps you to directly find the answer. You can see how simple it is. Now let's do a general solution. So what we normally do is that we are given a function f of x, which in this case is square root of x, right? So the derivative of this function is 1 over 2 square root of x. So that is the slope, right? So in our case, the derivative at x equals to 64 is going to be 1 over 2 square root of 64, which is equal to 1 over 2 times 8, which is 16. Is that clear to you? Right? So we have the slope of 16. Now, in general, if we're trying to find the slope at any point which is close to 64, right, we could use this point, right? So we can now say, let's figure this out first and then we'll generalize it. So from here we can say, since this is the slope and given situation, we can straight away write that the square root of 65 is basically equal to 8 plus 1 over 16, right? Which is 8 plus 0.1 over 16 is 0.625. 625, you know, right? Okay, that is 1 over 16. It's an easy number to remember since 25 square is 625, right? Do you get an idea? 25 square is 625, and that helps you to understand how we get this value. Okay, so 0.625 is this, and so we get the value of square root of 65 as equal to 8.0625. Perfect. Now this kind of approximation should be used only when the points are very, very close, right? Not otherwise. Otherwise, we are not going to get accurate values. Correct? You can always use a calculator to verify how close we are. This will always work for at least 3 decimal places. Okay. So that is one way. Now we are talking about the general formula. So generally we can write this as, now from here we can write that f of x minus, if it is any point a, right? So we could have square root of, let us say we want to find square root of x plus a. Right. So in this case it was x plus 1. But if it is a, then it is f of x minus f of a will be equal to the derivative at a times x minus a. Correct? So that will give you the answer directly. So in our case, f of a, the value was 8, right? Or you could write this also as f of x equals to f of a plus f dash a times x minus a. So you could use this general formula and find the value of any square root, right? So that is what it is. Now based on this, I would like you to find, let's just have a question here. find square root of 101. Correct? So find square root of 101. You can try square root of, let's say another number, which is 83. Okay. So of course the results will not be very accurate. In square root, we are always getting a higher estimate, right? So note higher estimate. Perfect. Since you see that the curve is under the tangent, right? So in such cases, you'll get higher estimate for square root using this particular method, right? So I hope all this makes sense, and it does give you an easy way of estimating. So we can estimate square roots with this method. Fairly accurately using the method shown here. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.